This is Algebra 2, Test 13. We got through Lesson 5.5. We're factoring these expressions. So these are, this is back from a few weeks ago. Number one says 6x squared plus 4x plus 10. You could take the number 2 out of these. You can divide everything by 2 just to make you have smaller stuff to deal with. 6x squared divided by 2 is 3x squared. 4x divided by 2 is plus 2x. And 10 divided by 2 is plus 5. Now, from there, that's not it, though. From there, you have to factor it out. And there's not, your A value is not 1. So this is probably this is probably one of the toughest problems on the test to actually factor out. But it's not ridiculous because there's only one pair of values you can use for 3x squared. You got to use 3 and 1. So 3x times x gives you 3x squared. Now, there's only one pair of values you can use for 5 as well. So we got to use 5 and 1. So we have to determine where do we put 5 and 1. If I put 5 here, I'm going to get the number 15 because 3x times 5 gives me 15 when you do the outer terms when you're foiling it. So that's not where it's going to go. We're going to put 5 here instead and 1 right there. That'll get me to the number 2. Now, the problem with this, though, is that since it has a plus right here, and that means that they're the same sign, and this one means that they're both positive. Let's see what happens when we FOIL this out. 3x times 1 is times x is 3x squared. That's the first two terms. 3x times 1 is plus 3x. 5 times x is plus 5x. And 5 times 1 is plus 5. Now, we're good at this point. 3x squared, that's going back to what it was. And we're good at this point, plus 5. But look what happens in the middle. When we try to combine the terms 3x and 5x, we get the number 8x, which is not what it was originally, 2x. So this one, as far as we can factor it, is simply where some of you guys stopped, this step right here. It can't be factored any farther than that because this is not correct because it doesn't give you 2x in the middle. So we can stop on that one at 3x squared plus 2x plus 5 by simply pulling out the 2 that they all have in common or dividing it by 2. The same thing, we're going to do the same thing with number 2, 20x squared plus 15x. We're going to pull out everything that both of these terms have in common. As far as the numbers go, 5 goes into both of those. So we'll pull 5 out. And as far as the variables go, x goes into both of them. So 5x. So you ask yourself, what do I multiply 5x by to get 20x squared? 5 multiplies by the number 4. And x has to multiply by x to give you x squared. If you multiply those two together, you get 20x squared, which is what we wanted. 5 needs to multiply by a positive 3 to give you 15. And x is already, it just needs to multiply times 1 to give you x. So this is the factored version, 5x times 4x plus 3. X squared plus 11x plus 18. When we factor this one out, you're going to do x times x. This one's a little bit easier. And then you have factors of c, 1 and 18, 2 and 9, and 3 and 6. Which pair of those gets you to the number 11? The only pair is 2 and 9 because 1 and 18 get you to 17 or 19. 3 and 6 get you to 3 or 9. Only 2 and 9 get you here. Again, this sign tells you they're either the same or they're different. Plus means same. Since they're the same, this one tells you they're both plus. Plus 2, plus 9. X squared minus 6x plus 8. When you factor this one out, you're going to do it the same way, x times x. Your c values 1 and 8 and 2 and 4. Which pair gets you to the number 6 in the middle? B, 6. Again, 1 and 8 will get you to 7 or 9, not 6. So 2 and 4 is the only pair that works. This one says they're the same sign. This one says they're both minus. Minus 2, minus 4. Number 5, x squared plus x minus 12. We're trying to get to the number 1 in the middle. So you have to have two numbers that are right next to each other where we can subtract them. 12's factors are 1 and 12, 2 and 6, and 3 and 4. 3 and 4 are right next to each other. When we subtract those, we'll get ourselves a positive 1 value. That tells us that the numbers are different, which means we're subtracting them, and the bigger value is plus. So plus 4 minus 3. Now, number 6 looks a lot like more like what we're doing this week. This one is a perfect trinomial. You can see you can take the square root of the first term, which is 5x, and you can take the square root of the last term, which is 3. This is the sign that goes in the middle. So plus 3, then just like what we're doing this week, 5x plus 3, and square it. Number 7 is the difference of two perfect squares. Again, you could take the square root of 9x squared is 3x, and the square root of 4 is 2. The difference between a perfect trinomial and the difference of two perfect squares is it's not going to be plus and then you're going to square it. It's going to be 3x and 2 and 3x and 2, but one of them is going to be plus, the other one's going to be minus. If you FOIL this back out, you get back to 9x squared minus 4. That's how you factor the difference of two perfect squares. One plus, one minus. Number 8 says to simplify 112 using the imaginary number I. Now this is a tough number to do. You might not know what number goes into it, the biggest one that goes into it first. I think it's 16, so just for the sake of speed. First thing we want to do, though, is since they have this negative value, we want to take that out by multiplying it by I. That's what we talked about last week, complex number I. Then I think 16 goes into it. When you separate this, you get the square root of 16 times the square root of 7. So the square root of 16 is both positive and negative 4 times the square root of 7, and don't forget this little I that comes down. So let's just dress this answer up and say it's both positive and negative 4I times the square root of 7. That's your best version of an answer in the neatest form. If it doesn't matter what order you multiply by, and you won't have to choose between different orders of multiplication. We're writing these in standard form, A plus BI. This one's a little bit easier. Undo the negative by multiplying it by I. So I times the square root of 36, which is I times both positive and negative 6 plus 7. So let's reorder that in A plus BI form. Your A value is 7, it's positive, and then it's both plus and minus 6 times I. A plus BI. 1 minus the square root of negative 8. So the first things first, get rid of the negative under the radical by multiplying it by the imaginary number I. So we have 1 minus that. We can separate, or we can simplify the square root of 8 into 4 times 2. 4 is a perfect square. It's 2 times the square root of 2. So we have 1 minus that. But again, it's both positive and negative. So to make this say standard form A plus BI, we could simply write 1 plus or minus, don't forget the I forgot to bring it down right here, plus or minus 2I times the square root of 2. Solving these equations, x squared plus 18x plus 81, you need to get it equal to 0. So in order to get it equal to 0, you got to bring 49 over by subtracting 49. If you subtract 50 from 81, you're going to get 31, but we're not subtracting 50, we're subtracting 49, so it'll be a positive 32. So we still have x squared plus 18x plus 32 is equal to now 0. So we could factor this out just like we were doing at the beginning of the test. Factor C, it's x and x. This is C, 1 and 32, 2 and 16. 3 doesn't go into it, 4 goes into it 8 times. 5, 6, and 7 don't. So which pair of those get you to B's value 18? Only 2 and 16 do. This sign tells you that both of them are the same. This sign says since they're the same, they're both plus. Plus 2 plus 16. And this is equal So now we have x plus 2 times x plus 16 equals 0. Write it as two separate problems. The first one, x plus 2 equals 0, and x plus 16 equals 0. So that's two very simple algebra 1 problems. Subtract 2 on both sides, 0 minus 2. X is either negative 2, that's one of the answers, or subtract 16 on both sides, 0 minus 16. X is negative 16. Two answers for number 11. And we'll finish the rest on part 2.